Hello, today I am going to demonstrate how to perform factor analysis in SPSS as a way to check validity of a questionnaire. Factor analysis is a group of statistical methods which includes both confirmatory factor analysis and exploratory factor analysis. And there are many details about those given concepts. In confirmatory factor analysis, we are trying to confirm a model by fitting it to our data, but SPSS does not include confirmatory factor analysis (CFA). But those who are interested to look at it can check it by looking at AMOS, IBM SPSS AMOS, which is one of the ads within SPSS. In EFA, exploratory factor analysis, we try to find groups of variables that are highly intercorrelated, like exploring which and how many factors are represented by my data. There are different mathematical approaches to do this, but the most common one is principal component analysis, or PCA. In this video, we will use one of the datasets that we have prepared for this video, and we will talk about principal component analysis, which is a method of extraction in exploratory factor analysis. In our dataset, just imagine that this is a motivation scale with two subscales, and it consists of 11 items. The original version of the questionnaire, as it is declared, represents two factors. One of them is effort with 7 items, and the second factor is self-efficacy with 4 items. We have 3 reverse items, and we recorded them before conducting factor analysis. We are curious about the factor structure of this questionnaire in our sample, since validity may vary depending on the sample. If we are using a scale in any study, it would be good to report the results of the basic validity analysis as well. And in a questionnaire, some items might be more closely grouping together, and we are going to check whether there are such components in this questionnaire. The purpose of factor analysis is to reduce many individual items into a fewer number of dimensions or factors. This is why we perform principal component analysis. A principal component analysis can be conducted to examine the underlying structure of a questionnaire. It's a data reduction method that creates factors. Within PCA, we can provide a preliminary examination of the underlying factors of a questionnaire by exploring its constructability. Later, the resulting subscales can be tested for internal consistency as well if you want to do it. Now let's look at how to do principal component analysis, factor analysis in SPSS. First, on the top menu, we should go Analyze, and later Dimension Reduction, and we should select Factor. In the Factor, we will see a pop-up menu again. Let's select all of your items and drag them to the right side. And later, in the descriptive parts, just select Chemo and Bartlett's test of sphericity, Kaiser-Meyer-Olkin measure for sampling adequacy, and Bartlett's tests. And these are the assumptions to examine the appropriateness of factor analysis. And so I just select this one. Later, in the extraction, as a method, principal component analysis is checked. And you can also change it if you want, based on the analysis that you will do. You can also select screen plot. Screen plot is a chart plot that determines the number of factors that retain in an exploratory factor analysis in EFA. Also, as a default, the eigenvalue is given as 1. and it will check the eigenvalue is greater than 1 for the factors. And if you want, you can also fix the number of factors, since in our case, for example, in this case, in this data sets, we used a developed scale beforehand, so we know the structure of the questionnaire. We have 2 factors, so you can just fix it to 2. If you didn't fix it, it will do it regularly, and the system will try to give how many factors do you have in this. So I just fixed it with 2, since I know that I have 2 factors, and I forced the program, the SPSS, to differentiate the items based on 2 factors. So continue. In the rotation, we can check Varimax. We have other methods of rotation, direct oblimin, Quartmax, Equimax, Promax, but the most famous one is Varimax. Maybe the second one is direct obligated rotation method, rotation solution. So just check this one. It is the orthogonal rotation to use with principal component analysis and factor analysis. It attempts to clarify the relationship between among the factors. And Varimax rotation use mathematical algorithm that maximize high and low factor loadings and minimize mid-value factor loadings for us. So as a detailed explanation about why we choose this one, never mind. So continue again. In this course, we don't need to select anything, and in the options menu, missing values will be excluded by listwise method as a default. You can also select sorted by size. By selecting this sorted by size, SPSS will order the items by their factor loadings. And also you can select suppress small coefficients. As a default, it is select 0.10, but any value below 30 does not make sense for us in factor analysis, so just try 30, and in this way SPSS we can ensure that factor loadings within minus and plus 0.3 are not displayed in our output menu, and in this way the output table will be less confusing for us. So just write it 0.30. Okay. Now let's click OK to see the output of our factor analysis. Now firstly, we will see the assumption tests, Kaiser-Meyer-Olkin measure and Bartlett test results. And any value for Kaiser-Meyer-Olkin, the value of Kaiser-Meyer-Olkin should be greater than 0.5, since we found about 0.86. So we can say that the sample is adequate to do this factor analysis, and the p-value for Bartlett's test of sparsity should be significant, and it is significant in our case. Therefore, we can say that factor analysis is valid. The commonalities shows us the loadings. Actually, for the commonalities, when we look at the extraction column, any value less than 0.50 actually viewed as insufficient. The lowest one is the second item, FR2, with 0.37, and also we have some values which are less than 0.50. So we should be careful about this, since this is just a fake data set to do it, prepared data set. So we might have such a low values for the extraction for the commonalities. Okay, let's go for the third table, total variance explained. Now, as you remember, we forced SPSS to extract factors with two factors, to distribute items to two factors. So it's a two-factor questionnaire right now, and results are based on two factors, and we can say that the total variance explained for the in the cumulative percentage is around 51. If you have multi-factor case, two or more than two factors, we can say that any value for the total variance explained, anyway, a value greater than 0.40%, not 0.40, sorry, 0.40 of the total variance is good for us in factor analysis. So this cumulative percentage, 51%, is good for us to explain the total variance of the questionnaire. And script plot is also shows us the values, the first factor. When look at the first factor and the second factor are above eigenvalue 1, so we have two factors, and the third one is just close to 1, so probably rather when we reply our steps without fixing factors to 2, probably we will have 3 different factors in our factor principal component analysis. So component matrix and rotated component matrix. Let's check the values on the rotated component matrix, and in the rotated component matrix you will see that the values, the loadings for the first 7 item, 1, 6, effort, 1, 6, 5, 4, 3, 2 and 7 are loaded in factor 1, and the last 4 items are loaded in factor 2. Sometimes, for example, when we look at effort 7 item effort 7, we can say that this item also loaded actually the other ones too. The second factor, when an item is found to have more than one significant loading, but we have critical issues about the sample size on this point, it's termed a cross-loading, which makes the factor analysis a bit troublesome. But the second loadings for those items are not big, so we can just eliminate those second factor loadings for effort 5, effort 3, effort 7 and self-efficacy 3, since they are around 0.3. So we have a large loadings for factor 1. So those items, those 7 items, represents the first factor, and the last 4 items represents the second factor, loaded in the second factor. We can just look at the, since we know the name from the names, that though the first factor name is effort, but you can just check the items, the content of the items, and you can decide the name of the factor if you are developing a questionnaire. And also the second ones, the second factors is about self-efficacy. Okay, if you are using a pre-developed skill in your study, which you did not develop it, in another meaning, you know that you use the reliable and valid scale in its original version. It will be better to choose to try not to drop items from this scale in order to preserve the originality of the scale. So try to keep all the items in the questionnaire if there is no big problem about the validity, about the construct validity of the item. As a last, so that's all we can say about reliability and principal component analysis, specifically principal component analysis method in factor analysis, exploratory factor analysis. We can roughly say that PCA and EFA can be used in two ways in factor analysis. First is conducting item subscale analysis to revise and strengthen a questionnaire or a test, and the second one, providing evidence for the construct validity. So that's all I can say. See you in the next lesson.